Hello, Mr. Hanna here again. We are now looking at quadratics. So basically a quadratic is a polynomial of order 2. So that means somewhere in it, it's got an x squared. But it does not have, so it does have x squared, it does not have an x cubed, it doesn't have weird stuff like 1 over x, or really weird stuff like 2 to the power of x, or any weird stuff like that. It's just got x squared, which you will get very, very used to soon. Alright, let's not bother rubbing that out too much more. Okie dokie, so the first thing in 2b is expanding quadratics. So expanding basically means getting rid of brackets. So some things are quadratics with an x squared term. They don't really look like it. So let's try the example where we have x plus 1 multiplied by x plus 2. Now it doesn't immediately look like a quadratic because you can't immediately see an x squared term in there. But if we expand it out, you will soon see that there is an x squared term in there. Now okay, so to expand it out, we're going to multiply the first term by everything in the other brackets, and then multiply the second term also by everything. So we're multiplying everything in here by everything in here. And what we get when we do that is multiplying x by x, x squared, multiplying x by 2, plus 2x, multiplying 1 by x is 1x, multiplying 1 by 2 is 2. Now we've got some like terms here, 2x plus another x, so those simplify down to 3x. We still have our x squared term, and we still have our constant term, which is 2. So this thing here that we started with in brackets looks like it was not a quadratic, but it is, because it does have x squared term. Let's also look at a couple of other things of note here. We also see that these first terms multiplied together give this term. We notice that the last two terms in each bracket give this term here. And we notice here we have 3x. So we notice that that is this plus this, and it's got an x in there too. So that's sort of how we came up with these 3 bits here. So we can sort of take a bit of a shortcut. Once you get used to this sort of thing, if you were to do x plus 5, multiply that by x, say minus 3, well, that times that is x squared, plus 5 times minus 3 is minus 15. So those are this term and this term. And the middle term is going to be 5 minus 3, so it's going to be a plus 2x. So there's a little bit of a shortcut that we can take if it looks the same as this. Now we can also get our calculators to do this for us. So let's just try. Let's try the first example in our CAS, x plus 1, and we'll multiply that by x plus 2. There we go. We get the exact same thing. The reason is we didn't tell the calculator what we wanted to do is we expand it. So now we're going to go into algebra because we're doing algebra. And if we want it to expand, and now I'm just going to go Control C. Now I'm going to go back down. And now I'm going to go Control V. So there is this copy and paste function in this calculator. Bit of a handy shortcut for you. And there you go. It has been expanded. Kind of handy. Okay, so next we should learn when we can't use this trick. Okay, so we've used it. Now let's learn cases when we cannot use it. Okay, let's get a new screen happening. Alright, so some cases where we can't use it. Let's consider, first let's consider negative 2 times our first example, x plus 1, x plus 2. So our first example. So let's look at what we had before. There we go, that was our answer from before. So the best way to do these problems is first do this stuff, all the expanding, do that first, and then multiply it by our minus 2. So we've still got our times minus 2 at the front, and we have our answer from before because it's the same factorized quadratic that we had here. So this bit becomes our x squared plus 3x plus 2. Now we need to multiply this minus 2 by everything in the brackets. So remember, you multiply everything by everything. Okay, so we get minus 2x squared minus 6x minus 4 for that example there. Okay, so we did the exact same thing to everything in the brackets, we expanded it, and then we multiplied everything by our negative 2 factor. Okay, so now, let's put that example to the side. Let's look at another case where you can't just straight away use our clever trick where we multiply the first two things to get that, the second two things to get the end one, and then just add together these terms to get the middle term. Okay, so our next example that will show us where not to go wrong will be this one, 2x plus 3 and x minus, actually, hang on, let me change this example, that can be a 4 there, sorry about this, that's a 4, and x minus 3, that'll do. Okay, so here we notice that it's a different form to this. Here we just had an x and an x, but here we've got a 2x and an x. So, in order to be able to use our trick that we've learnt, we need to take out a common factor here. So we notice that we can take out 2. So we can make it 2x plus 2. So here we've divided this term and this term by 2, taking that out the front. Then our next one by x minus 3, that's just the same. And now we can use our trick. So we leave the 2 out there, x times x is x squared. 2 plus minus 3 is minus 1x. Plus 2 times minus 3, minus 6. Then multiply the 2 through everything, 2x squared minus 2x minus 12. Now, I just wanted to show you that so that you're very familiar with the trick. Of course, it probably is easier to do minus 2x times x, 2x times minus 3, 4 times x, and 4 times minus 3. So we can do that too. You'll see 2x times x is 2x squared. 2x times minus 3 is minus 6x. 4 times x is plus 4x. And 4 times minus 3 is negative 12. Now we've got some like terms in the middle. So now we'll simplify these like terms and we get minus 2x minus 12. So you can use either method and they both work out perfectly fine, perfectly well. Alright, so that's it. You can now complete 2B.